In 1513, Juan Ponce de Leon sailed from Puerto Rico, where he had recently been removed as governor, to search for new lands to claim for Spain. It was the beginning of an expedition that later was to be his legendary search for the Fountain of Youth. On April 3rd, he landed on what he believed to be an island, which he named La Florida. Exactly where they landed on the Florida coast remains a matter of dispute. After 5 days on land, which they claimed for the King of Spain, they sailed to the south, seeking to explore the size and shape of the island they had discovered. They were not seeking a Fountain of Youth, and they did not discover one. Neither were they able to discover that the land they had found was part of the North American continental mainland. Nevertheless, they made a significant discovery, one which Ponce de Leon failed to understand. On April 22, 1513, de Leon noted in his journal that his ships had entered a current more powerful than the wind. Ponce de Leon observed that his ships, despite being driven by favorable winds, were unable to make headway against the current, and one of the 3 ships of his expedition was driven backwards by the current. It was the first known encounter by Europeans with the ocean current today known as the Gulf Stream. The Gulf Stream has since played a large role in history, including the development of shipping trade routes, piracy, fishing, and others. Over the centuries, its role in the development of ocean habitats and climate has been studied and debated. A fairly significant portion of the northern hemisphere would be largely uninhabitable if not for its existence. Recent evidence from oceanographers and climate scientists indicate that it is steadily weakening, with some claiming that it is in its weakest state in 16 centuries. Others claim it is strengthening, getting both warmer and faster, neither of which is a good thing, by the way. Welcome back to Geographics. I'm your host, Eric Malachite, and today's script was provided by Larry Holsworth, so be sure to show him some love as you deploy your likes and do all the things that help keep the eldritch beast that is the YouTube algorithm going. Let's get to it. Ponce de Leon did not wander about Florida searching for eternal youth, but he did allow the Gulf Stream to carry his ship some distance before breaking free and continuing his expedition of discovery. His report and those of the captains of his other ships were of interest to Spanish mariners. In the tropics, the prevailing winds blew from the east. Mariners departing the Spanish possessions in the New World faced a tough journey battling the contrary winds. The current discovered by Ponce de Leon offered an alternative. Ships traveling to Europe could use the current as an ocean highway to the north, where once the mid-latitudes were reached, they would find the prevailing winds blowing to the west. These westerly winds would then drive them home to Spain. The route favored by the Spanish captains, whose ships typically left the Caribbean for Spain laden with wealth, drew the attention of less honest mariners in the 17th and 18th centuries. Piracy flourished in Florida, the Carolinas, Virginia, and in the islands passed by the current. It was like a highway bringing their prey to their lairs. The treacherous waters of the American shoreline were often made more so by the current. Its swift movement caused innumerable eddies and pools, drove ships ashore or onto rocks, and led to the start of shipwrecking, particularly in the barrier islands of the Carolinas. To the north, other types of mariners encountered the current as well, though they did not chart it nor give it a name. They learned to identify it by sight, with changes in the color of the water. When sailing from the growing North American colonies to Europe, it was an advantage. When sailing in the other direction, it was best avoided. In the days of sail, ships were as much at the mercy of currents as they were of tides and winds. The pattern of prevailing winds in the direction of the flow of ocean currents favored the development of the triangle trade with the New World. Ships departed Europe for Africa, then used the trade winds to reach North America, and then the current and westerlies to return to Europe. Mariners plying this route made use between Africa and the Caribbean of another current which conveniently flowed in the desired direction. The current through the Atlantic was well known to mariners and navigators by the heyday of British colonial America in the mid-18th century. It was uncharted, but sailors knew how to identify it and where to look for it, as well as how to either use or avoid it depending on their mission. But beyond those whose livelihood depended on the sea, it was virtually unknown. In 1768, Benjamin Franklin, already a scientist of note due to his work with electricity, was in England, serving as Postmaster General for the colonies. Mail between England and the colonies typically departed England from Falmouth, a port in Cornwall in the southwest corner of Britain. It was shipped in scheduled vessels known as mail packets. Franklin received a complaint from the Royal Board of Customs, framed as a question. They wanted to know why merchant ships departing London for Newport, Rhode Island, or New York routinely encountered shorter voyages in terms of days at sea than the mail packets which began their voyage much closer to their destination. The merchant vessels had to work down the length of the Thames River and estuary, then the length of the British Channel, before reaching the open Atlantic, a voyage of many more miles. From London to Falmouth alone was a distance of over 350 nautical miles. What the Board of Customs wanted to know was, in essence, why is the mail so slow? Especially given that the mail packets were smaller ships designed for speed rather than heavy cargoes. Franklin didn't know the answer, and given his character, not knowing was absolutely unacceptable. He directed the question to a mariner, a Nantucket whaler who happened to be his cousin, Timothy Folger. Folger told Franklin that the mail packets sailed against the Atlantic current when they encountered it, while the merchant ships crossed it as quickly as possible. Folger informed his cousin that the current the packets sailed into sped along at about 3 miles per hour, or roughly 5 kilometers per hour. Franklin, intrigued, began questioning other ship captains and navigators who had encountered currents during voyages to and from North America. He also worked with Folger, and together they produced a chart depicting an Atlantic current which originated near the Straits of Florida, journeyed up the North American coastline before turning to the east, widening as it headed towards Europe, and eventually turning further to the southeast. Franklin named the continuous current the Gulf Stream. Franklin and Folger published their chart in London in 1770. British captains widely ignored it, as well as Franklin's published recommendations on how to navigate the current. Subsequent oceanographers proved that while much of Franklin's chart depicted the Gulf Stream accurately, much else was incorrect. It did turn to the southeast, but it did not widen dramatically in the Atlantic. Franklin had the opportunity to personally encounter the Gulf Stream on his voyage home from England in 1774, and again during his voyage to France in 1776. During these journeys, he took temperature readings and extracted water samples at varying depths to determine salinity changes. He also observed the speed of the current to be greater than what Folger had reported to him. By then, though, revolutionary and diplomatic activities took up most of his time. He continued to be interested in oceanography and in 1785 published his findings regarding the Gulf Stream along with other ideas which he called maritime observations. The Gulf Stream is a part of a series of currents in the Atlantic Ocean. It is believed to have been formed around 2.5 million years ago, about the time when the Isthmus of Panama formed, separating the Atlantic and Pacific Oceans. The Gulf Stream itself builds near the mouth of the Gulf of Mexico, follows through the Florida Straits, which separate Florida from Cuba, and then north and northeast along the southeastern Atlantic seaboard of the United States. It is what is known as a western boundary current, which makes it subject to a process known as western intensification. Such currents carry warm tropical water toward the poles. By contrast, eastern boundary currents carry water toward the equator. Around the mouth of the Chesapeake Bay, the Gulf Stream veers further to the northeast, crossing the Atlantic in the general direction of Newfoundland. During its journey northwards, it shifts its position relative to the coastline. During the warmer months, it is closer to the U.S. shoreline than it is in the colder months of winter. The reason for this shift is largely uncertain, and its actual movement has increased in the past several decades. That is, the distance it moves has increased. It is not driven by the warm waters of the Gulf, as is widely believed. It is driven by wind stress along the surface, heat transfer, and the Coriolis effect. In simple terms, the Coriolis effect is a force created by the rotation of the Earth, which causes deflection, or a curving path in moving objects. In the northern hemisphere, this deflection is to the right. In the southern hemisphere, it is to the left.
We need you to check your sinks and toilets and tell us which way the water is going, and please, stand clear!
The stream is relatively consistent in width, about 61 miles wide. It travels at a relatively consistent speed, about 5 nautical miles per hour. This flow is generated by the evaporation of waters along the surface driven by the prevailing winds. Heat flows from hot to cold. And that is why ice melts in a glass of water. The warmer water melts the surface of the ice, gradually dissolving it. If the reverse were true, if temperature flowed from cold to warm, ice placed in a glass of water would freeze the water in the glass. The transfer of heat along with the wind stress on the surface and the Coriolis effect is what drives the Gulf Stream on its journey. As oceanography Henry Strommel observed in 1958, very little water from the Gulf of Mexico is actually in the stream. And yes, we're calling it the Gulf of Mexico. A strong current known as the Atlantic North Equatorial Current streams eastward from the west coast of Africa toward the northeastern coast of South America. When it reaches South American waters, it splits. One branch, known as the Antilles Current, flows northward, staying to the east of the West Indies. The other enters the Caribbean and flows into the Straits of Florida from the west, where it reunites with the Antilles Current, forming the Gulf Stream. In the Atlantic, near the Azores Islands, the Gulf Stream splits, with part going to the north as the North Atlantic Drift and part turning to the south, known as the Canary Current. The latter returns to the waters off Africa, where the Atlantic North Equatorial Current is formed. These massive ocean currents, along with several subcurrents which they feed, form what is known as the North Atlantic Gyre. However, more recently, scientists have designated the entire system, including all of the subordinate currents, as the Atlantic Meridional Overturning Circulation, which is very difficult to say. The North Atlantic Drift, also called the North Atlantic Current, carries the warm waters from the Gulf Stream into northern European climes. It is perhaps the most influential branch of the North Atlantic Gyre on the habitability of northern lands. Much of northern Europe is located in latitudes considerably north of the United States, and even of the more heavily populated regions of Canada. All of the United Kingdom, most of France, the Low Countries, and of course Scandinavia are well north of the United States, with the exception of Alaska. The North Atlantic Drift is widely regarded as contributing significantly to these areas being habitable. The warmth generated by this northern leg of the Gulf Stream is measurable and has been observed for many years. In the UK and in Ireland, for example, temperatures on the western edges of the landmasses are routinely warmer than those on the eastern side. The drift flows along the western side and north of Scotland, where it also helps keep waters in ports from becoming ice-locked in cold months. It then enters the waters off Norway, where it contributes significantly to helping to keep critical infrastructure open in the coldest months of the year. Norway's port and city of Tromsø is located near the top of Norway. It is north of the Arctic Circle. It is built on an island just off the Norwegian mainland. Yet, the waters are ice-free throughout the year, kept that way in part due to the influence of the North Atlantic Drift. It isn't only the waters which are kept warm by the drift, though. The lowest temperature ever recorded in the city of Tromsø occurred in February 1966, when a low of negative 18.1 degrees Celsius was reached. That's equivalent to 1.1 degrees below zero in Fahrenheit. Colder temperatures than that are routine during American and European winters in many areas. Even Florida has a state low temperature record of negative 2 degrees Fahrenheit. How much the Gulf Stream and its related currents contribute to climate in the Northern Hemisphere is debated by those who have differing views over climate and global warming in general. Although, I will say that while we sometimes make mistakes in our research, we will always defer to experts on an issue like this, even if our government decides to platform absolute clowns instead of people who actually know what they're talking about. A spheredrup is a unit of measure. Specifically, it is used to measure volumetric flow in oceanography. It is abbreviated as SV, capital S, lowercase v. One spheredrup is 1 million cubic meters of water flow per second. While that in itself is somewhat mind-bending, it needs to be applied to the Gulf Stream. The Gulf Stream moves water at a rate of 30 SV as it transits the Florida Strait. As it moves northward, its volume increases so that as it moves to the northeast below Newfoundland, it reaches 150 SV. That's 150 million cubic meters of water per second. That volume exceeds that of all the rivers combined on 4 continents, which drain into the Atlantic Ocean by several levels of magnitude. The combined rivers of Africa, Europe, and North and South America, which drain into the Atlantic, total a comparatively paltry 0.6 SV. The current is deep, between 2,600 and 3,900 feet. As a rule, water within the current has a greater salinity content than water outside of its flow. This quirk provided mariners with warnings as to its proximity for many years. Sailors approaching the current from the east learned to watch for clusters of seaweed lying along its eastern boundary, as the current does not carry seaweed along with it. Mariners approaching from the west watched for changes in the color of the seawater stretching across the horizon. Most of the Atlantic Ocean is grayish-green in color when viewed from its surface. By contrast, the Gulf Stream is a cobalt blue. During periods of rough weather, which was and is common in the North Atlantic, neither of these methods were of much value. The Gulf Stream continues to run its course despite Atlantic storms, including nor'easters and hurricanes, which frequently cross its path. Neither deflect it from its path, despite often mountainous seas and strong winds. Within hours of a passing storm, the steady flow of the Gulf Stream is again detectable and measurable. Indeed, hurricanes have been known to follow the Gulf Stream, gaining strength from its warmer waters. Hurricane Sandy in 2012 was one such example. Sea bottom changes can and do affect its course. One such bottom feature is located about 90 miles to the southeast of Charleston, South Carolina. As the Gulf Stream approaches Charleston from the south, it travels over a bottom more or less stable at about 2,300 feet. It suddenly runs into an escarpment, which rises sharply to a depth of about 1,200 feet. The depth then drops sharply again, creating several underwater scarps and caves. This feature is known as the Charleston Bump. The bump deflects the Gulf Stream away from the coastline as it approaches Charleston, though a small portion of the flow is shaved off, so to speak, directed toward the shore, creating numerous eddies and backwaters. The Charleston Bump is a significant fishing area, in part due to the marine environment created by the bump. It supports sailfish, swordfish, marlin, and numerous smaller species, and is a commercial fishing area for swordfish. In 1620, when the people we know as the Pilgrims journeyed to the New World, they were supposed to be bound for the mouth of the Hudson River. They made landfall instead near Cape Cod. They made an attempt to sail south from the Cape, but failed to round it, not due to unfavorable winds, but due to unfavorable currents. The Gulf Stream may well have been the cause of their arrival too far north, as well as their inability to move further south. There were numerous references to opposing currents during their voyage. At any rate, they stayed where they were in Massachusetts. During the age of sail, ships traveling from south or west of the Florida Straits to the north or to Europe routinely followed the Gulf Stream, taking advantage of the boost in speed. Ships arriving from the north were well advised to remain outside of the current. This meant they either had to hug the shore in frequent treacherous waters or remain well out to sea, even in seasons known for stormy weather. From the Florida Straits to the mouth of the Chesapeake Bay, the bottom of the Atlantic is liberally dotted with wrecks and sunken ships, some of which have yet to be found. The U.S. Coast Guard considers the Gulf Stream to be a contributor to the many legends of the Bermuda Triangle, which the service does not recognize. In their estimation, many ships and boats which became lost are due to inexperienced operators not realizing how far off course the Gulf Stream made them. Nor do they recognize that attempting to operate a boat against the current requires far more fuel than when running with it or when outside of it entirely. During World War II, German submarines operated within the Gulf of Mexico as well as along the east coast of the United States. Their commanders frequently used the Gulf Stream to depart the area when returning to Germany, often having claimed several victims along the American coast, at least early in the war. The Germans also used the ice-free fjords and ports of Norway, kept ice-free by the North Atlantic Drift, as a haven for several surface ships during the war. Probably most famously, the battleship Tirpitz was kept near Tromsø as a fleet for several years of the war, forcing the British to keep on hand sufficient force to deal with it should it decide to sortie. In short, just through its mere existence, the Gulf Stream has had a significant impact on human history. It has influenced trade routes, exploration, colonization, warfare, climate, and, as a result of the latter, cultural development, especially in Europe. In July 2023, the British newspaper The Guardian reported on a study which suggested the Gulf Stream could collapse, part of an overall collapse of the Atlantic currents, as early as 2025 and probably before 2050. The study cited had been published in the journal Nature Communications. It blamed the threat to the Atlantic current system on the melting of Greenland's glacial cap, as well as other factors contributing to global warming and climate change. Unfortunately, those two terms have in many quarters been removed from the subject of science and inserted into political debate. In the United States especially, but in other countries as well, those who warn of climate change are often denigrated and derided. As they often say, a prophet is not believed in their own land. To climate change deniers, the subject is akin to a red flag to a bull. Sensible and logical discussion is impossible, since to them climate change is a hoax. If the North Atlantic Gyre were to collapse, as is believed now to be likely sometime this century, the effects would be catastrophic. Like, forget Yellowstone erupting. This would be way worse. The rain patterns throughout much of Europe and East Asia would be disrupted, with the following disruption of the food supply. Much of Northern Europe would no longer benefit from the warmed air, and farms would be unable to supply crops. Scandinavia's climate would become colder as well without the stabilizing effect of the Gulf Stream, and the ice-free harbors would be ice-free no more. The study cited by The Guardian is not the only one to find the Gulf Stream in considerable danger of collapse. In 2023, the prestigious Woods Hole Oceanic Institute released the results of more than 2 decades of measurements conducted by submersibles. They found that the Gulf Stream is warming faster than the rest of the ocean, and that it is shifting closer to the east coast of the United States. The Woods Hole study does point out that the forces which create the Gulf Stream, wind patterns, and the rotation of the Earth will not go away, and the Gulf Stream will continue to exist. Yet it may become too warm, contributing to unpredictable climate changes as a result of global warming. Shifting closer to the US coast could eventually contribute to increased shore erosion and rising sea levels. A more recent study, released in January 2025 and conducted by a joint US-Swiss team, indicates the Atlantic current system has not declined in the past 6 decades, but is expected to as the world continues to grow warmer. Yet even that would not be a total collapse of the currents in the Atlantic, but a weakening of the system which would have devastating effects on climate and thus on economies across the world. For climate scientists, the point beyond which attempts to alleviate global temperature rise are futile are known as tipping points. Many now warn that the tipping point for preventing catastrophic changes to the Atlantic current system is in the past. Perhaps that's the case, but unfortunately only time will tell for sure. I hope you learned something today, and if you enjoyed this video, be sure to deploy your likes, comment a historical location we haven't covered yet, subscribe and ring that bell, and share this video with someone who loves learning about history's most important locations. I'm Eric Malachite, and we'll see you next time.